So today I've got a fun scientific experiment to share with you. Now this scientific principle has really changed aviation and law enforcement cameras, forestry, and also satellite systems on orbit. Have you heard of infrared light?
It sounds kind of familiar, but could you refresh my memory?
Yeah, absolutely. So the word infra actually means below in Latin, and that's really helpful for us to know. Infrared light is below the red color spectrum, and for us that means it's a signature that we actually can't see with our eyes or with normal everyday cameras. Now, infrared technology is specifically used for cameras was first explored in the 1950s, and then in 1963 they invented the first infrared camera, and it was specifically called a forward-looking infrared camera. And what you have here is an example of a device that uses that exact technology. It's called a Flir camera.
So just looking off the screen, we got some temperature gauges there. Does that have something to do with looking at thermal imaging?
Very good, absolutely, yes. That's really the benefit of using this type of device. It can detect thermal signatures and heat signatures and tell you how hot objects are, body parts, even the surface of the Earth. And so we're going to do a quick demonstration today to show you how this actually works. So I have got a canister here with some liquid. Can you tell how hot the liquid is?
No clue.
All right, with just the normal eye, you really can't tell.
Not a thing.
But if you use the Flir camera, take a look. What do you notice?
So it's right there. It's looking pretty cold based off of our scaler on the right there.
Exactly. I actually happen to have ice cold water in this canister, and you can tell with this camera exactly how cold or hot it is. Let's try another experiment. I've got a mug with some water in it. Can you tell how hot this mug is just from looking at it?
There's no steam coming off of it. It doesn't look like it's freezing your fingers at all. No clue.
All right.
As to how hot it is.
It's definitely not freezing my fingers, but it may be burning my fingers.
Yeah, it's pretty warm.
You see that?
Right. Yeah. Very cool.
You can tell that this is definitely hot water in the bottom. And again, you really couldn't tell just looking at it or if you took a picture of it.
Mm-hmm.
So we're not only going to use this for objects, but now let's do an experiment using your hands. Go ahead and take a look at what your hands look like under a Flir camera.
Right. Whew. Looks like my fingers are pretty cold.
Yeah.
But as I go further up my hand, it seems to get a lot warmer.
Yeah, definitely. You can tell it's a little bit chilly in here, and
yeah.
You can see how that heat is really concentrated in your palms. Now, let's take a look at how rubbing your hands together affects the signature. So right now that friction is moving that heat from your palm into your fingertips. There you go.
They're a lot warmer now.
Look at that. You can actually see how that thermal signature was dispersed into your fingertips.
Especially compared to the back of my hands.
Absolutely.
All right.
Now this again has really changed a lot of industries, so you can imagine all the cool things you can do with this. One of the most interesting ways that infrared light is used is specifically on orbit with our satellite systems. Now, have you heard about the forest fires in California?
Yeah, I have heard of those.
Yeah, they periodically have forest fires, and the fires can be very large, and to assist firefighters and government workers in making decisions, sometimes imagery is really helpful. Now, infrared technology can be used to cut through the smoke that would normally block our ability to image an area to see where the forest fire is originating from. But the infrared light can actually cut through that, tell you how hot the forest fire is, and even where it started. And even more interesting than that is actually what we can do with it in space. NASA uses infrared technology to explore the galaxy and the universe to see how hot planets are, star systems, and to even cut through space dust to see what those temperatures look like.
Sounds like this piece of tech has quite a bit of future for it.
Absolutely, it's definitely here to stay.
Thanks for sharing it with me.
You're welcome.